So I was sitting in calculus class and I had this idea as we were looking at the sinusoidal functions like sine. And the sine function is like a wave motion. And I remembered, oh yeah, the Medusa heads from Castlevania have the same exact motion. And so if you've ever played Castlevania, you'll know about the Medusa heads because they're awful. They're brilliantly designed, but they're designed to be so deadly and just knock you off platforms and just be the worst enemy in the game. One of the worst. And part of that is because of how seemingly unpredictably they move. But they do move predictably. It's an actual function. So let's see if we can replicate that. Let's get into it. I think we're gonna need start x, and that's gonna be the x when it's created. Same for y. And we can use these to shift the starting position of the movement. And in here we're gonna do y equals it's probably make some more stuff here first. We're gonna need an amplitude. Let's make it 64 pixels for now. So we'll do y equals amplitude times the sine of the x value, and we'll just increase the x value by let's see, 4 every tick. And I'm curious to see how this looks so far, so we're gonna give it a look, not set before reading it. Huh. Did we? Oh, we're doing it the wrong way. That is a terrible mistake. Wow. Will I cut that out? Maybe. Or I'll just leave it in so everyone can laugh at my mistake. Well, I'll have to leave it in because then I'll have to show the change. Whoa, that's way too fast. And also the position, like I expected, is not the same. So, I think we have to add start x here and add start y there. And then I'll see what that does. Because that's basically just a shift to the starting position. And I don't see it anymore. Good. If we divide by a value, actually we should make that a variable, shouldn't we? Let's call it a rate. And we'll make that 6. Yeah, it does slow down, but we still can't see it. Oh, you know what? It's because we're not drawing itself. Duh. Of course we wouldn't be able to see it. Simple mistake. There it is. Wow, look at that. That's pretty nifty. Not quite a Medusa head yet, though. Let's make it a little bigger. By a little, I mean a lot. And we'll change the motion, increase the amplitude back to what it was. I think the rate should be pretty good. Let's see how this looks. I made it too big. Change this back to 128. Let's see if we make this a big number, like 25. Because currently it's... Are we making it faster by doing this? Pretty sure it should be slower. Yeah, there we go. Now that's a Medusa head. Yeah, that's pretty good. Now that is a Medusa head. Look at them go! Look at that! It's beautiful. Look at that sine wave. Let's go over the code a little bit. This is the spawner. We'll go over that in a second. So here we've got the Medusa head object itself. Start X we don't really use, but it's just there. Thought I would need it, but I actually don't. Start Y is set to the Y position when it is created. So this will be whatever position it is when it first gets created. The amplitude is going to affect how the highest and lowest point of the movement. So this, in this case, 64 pixels. The rate is going to affect how quickly the wave is oscillating. In this case, a higher number means it will be slower because we're dividing, in this case, by a 30th the rate. Speed is going to be, SP is the speed of the horizontal movement, how fast X is increasing. Every tick. And image speed, I set it to 0.05 because there's 2 frames of animation, and so it should be a really slow animation for 2 frames of animation. Here's the actual code for the movement. X is going to keep increasing by the speed value every tick, and the Y value of the position for this object is going to be the amplitude multiplied by the sine of the X value divided by the rate plus the starting Y value. And the starting Y value is important because otherwise it'll start at 0 always. And that way you can put it wherever you want, or it'll start where it's created instead of at 0. And then I just have this for debugging purposes to show me the X and Y value. Alright, let's head on to the spawner here. We have alarm 0 set to 180, which means every 3 seconds, because we've got 60 frames per second in that particular room. When the alarm is triggered, we set the alarm back to 3 seconds after spawning a Medusa head. And we also have it so that when we press the mouse button, the left mouse button, we create a Medusa head at the position of the mouse. Alright, see you next time.